installing Pandas as it is with any other package installation. Pandas installation is also very simple. It's if you are installing it in Linux, all you have to do is sudo apt-get install Python Pandas, or if you are installing it in your PyCharm, all you have to do is like I've been showing you, just go to your settings and then just install Pandas. Okay, here it is. Just install. Just search for it, PANDAS, and just install. So that's about Pandas installation. Now, what is Panda? Right? Pandas is an open source BSD licensed library providing high performance, easy to use data structures and data analysis tools for Python programming language. And like I've been telling you, it's built on top of NumPy, SciPy, and to some extent Matplotlib. Right? It has taken some of the better features of NumPy, SciPy, Matplotlib, and then they have created Pandas. Pandas is well suited for many different kind of data. One is tabular data, ordered and unordered time series data, arbitrary matrix data, and other forms of observational statistics data sets. Now you'll see some of these things, right, while I load the data, and the way some of the statistics are being done using Pandas is it's extremely powerful, and it's beautiful. You do not have to calculate all those mean, median, standard deviation, etc. One statement and everything is done. So that's how simple Pandas make. And also it can also do some of the stuff that Excel does. It's like almost like whatever pivot does, Pandas is able to do that. So that way on a metrics data, it's pretty powerful. Now, the purpose of Pandas, we have been talking about analyzing data, cleaning, munging, modeling, so as to be able, so that we can feed this data to machine learning, right? Who does that? Pandas can also do it. Your ordinary Python program can obviously do it, because that's what Pandas is based upon. It's built on top of that, but Pandas has been specifically designed to to work on metrics and other statistical data. Now, primary data structure of Pandas. Pandas has two primary data structures. One is series, which is one-dimensional, and the second is data frame, which is two-dimensional. Okay. When you think of data frame, you can think of some Excel in your head, and you'll be able to understand. It's a two-dimensional data structure. In one-dimensional series, it's one-dimensional labeled array capable of holding any data type, right? So now let me go here. Okay, 1 second, right? So if you do this, okay. So all I'm doing is I'm trying to put this list ABCD into list, and then I'm printing that. Okay, okay, here you go. So whatever ABCDE here is in my list, right? You get that along with its index. Okay, and the data type of that is object. It's an object data type. So this list is printed as along with this index here. So let's go here. So this is series. Basically, you can have any series. You can provide your own index. You can provide customized index. You can also have numerical or non-numerical index. You can have special characters as index, so on and so forth. Basically the point here is that you can have an index created on the data. That's series, and it is one-dimensional. I see a question here, but I'm coming back to that. And a two-dimensional data frame, it's a data frame which is two-dimensional. It's a two-dimensional level data structure with columns of potentially different types capable of holding, right? It's basically two-dimensional. Think of an Excel sheet. That's how you can think of this. The basic method to create a data frame is to call data frame. Now the difference here is for series or one dimensional you call series, and for data frame you call data frame. Now yes, Vishnu, it converts in something like a key value pair. Yes, you could see that. Values and index, right? Index values. Now D and index can be any dictionary of one dimensional array. Okay, here in this case D and index can be any dictionary of one dimensional ND array, list, dictionaries or series, etc. So we will see that while we are going through this example. Now these are a lot of stuff here. Okay, we'll go and see them one by one. Now see, like I told you, right, in this example, these are my values. Okay, this is again some other type of list. These are again some other type of list, 9, 7, 8, 6, some values, and then my index is star, double star, triple star, etc. So let's go and see as to how it works. Now, if I print series here, it gives me, see, star is 9, double star is 7. That's how it has been given here, right? This value has this index. Now, if I go to series and then say, what happens here? Star. Okay, let me try to differentiate that. Now, if I do in this case here, if you look at this closely, the index has star, double star, triple star and 4 star, with each of this representing some data here, 6, 8, 7 and 9. So if I have to pull this data based on some index, as I do for any other normal index, right, I say series of star and then it gives me 9. If I say series of double star, likewise it will give me some other value, which is in this case 7. Okay, so now, and then if I have to fetch multiple values, right, I can do this here. Inside list I'm passing both star and double star. You see here inside my list, see, that's how I'm able to access the data. Now these are some of the simple operations here, and we'll see the powerful operations now. Okay, let's first cover some of the basic stuff. Okay, one more example here. In this case, right, now you see what I'm doing here. I'm trying to print 2, 4, 6, 8, and then I get that along with index, right? 2, 4, 6, 8, 0, 1, 2, 3, 4, 3. This is the index, and I have assigned 2, 4, 6, 8. Now, if I specifically assign some values, in this case, some characters here, now that becomes an index. So, likewise, like how I did for some star, I can do this here as well, right? I get 2. Okay, that's how it can go. So, these are some of the simple operations, and in this case, right? Let's just a second. 0, 1, 2, 3, 4. I have these values. Let me go to my example here. Now, let's say, for example, I have something like this. Now, what happens here in this case? You have range is your values 0, 1, 2, 3, and your list has, index has a list which is AB, AB. So when I do print of S3, this is very important when you are slicing and dicing the data, right? Mostly if you are trying to do machine learning and you are trying to deal with some kind of data where you want to do statistical analysis, then this is the package that you need to go. Now look at this here I have range which is 0, 1, 2, 3, which is my value, and list A, B, A, B. You know, I have duplicated index as well, A, B, A, B. Now, how do I access A's, all A's here? I just do an A, and then I get both the values here. In this case, right? Okay, 1 second, let me print S3 first. Okay, so now in this case, if you see here, A is 0 and A is 2. A is 0 and A is 2. So when I just do an S3 of A, I'm getting both 0 and 2. Now what if I only want the first values? How do I get it? Let's say I just want 0. Any idea, guys? Okay, I'll give you 30 seconds. So my problems here is that my S3 has some data 0, 1, 2, 3, and this is the index A, B, A, B. Okay. All I want to know here is when I do print S3, I'm able to get the entire one-dimensional array, right? One-dimensional series. And if I do S3 of A, I'm able to get A of 0 and A of 2. If I do print S3 of B, okay, I get B1 and B3. Guys, are you able to at least hear me? A smiley or whatever, a small character Y will also do. I'll be able to understand that you're still with me. Okay, Naveen says I'm with you, Dipesh. Okay, Sundar. Okay, thank you guys. So, Sayed. Okay. Anyways, so guys, here I have, when I do S3 of A, right, I'm able to get both these values. So any guesses as to if I want only one value here, how do I do it? How do I access a list? So let's see what happens when I do this. Okay. Will this work? Yes, it does. See, it's just giving me one value. Let's say B of 0 as well. See here 0 and 1. S3 of A of 0 is 0, S3 of B of 0 is 1, right? That's what it is. Something like, okay, Vishnu, it's, okay. Vishnu has given a response. You are just near to that, but this is how it will work. Nearly worked. This is how we'll access the matrix later, Vishnu. You are not completely wrong. This is how we'll access the matrix. Okay. So now, yes, two-dimensional array, correct. Now, see, we have been seeing, what is it that we have been seeing? We have been seeing that we provide the values and then we provide index. What happens when we do this? A dictionary like value already passed. See here, it gives me S of data as a dictionary only. So, will I be able to access the values individually? Yes, I am able to do that. So even while you pass these values, right, even while you pass some dictionary like values instead of list, like all we have been seeing here in the example is list, right, everywhere. This is list, 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 and so on and so forth. Now even if you pass dictionary, you are able to do the same thing that you are able to do with a list. Now and then if you have to make this as, but this was a plain dictionary, right? This was a plain dictionary. If you have to insert this in your series, which is a panda type, all you have to do is you have to provide this data inside my series, and then it will just work as one-dimensional series. See here. Just to not confuse you. Okay, so like you have been working on list, this is an example of how you can work on dictionary as well. Simple example moving forward. Okay, there is one more thing that you can see here. See, this is S data is your dictionary here, and then you have provided A, B, C, D as your list, right, which is an index. So when you do print, we'll see, we'll try to differentiate this and this, and then what happens is that your B, C, D, it matches. Okay, so let's go here, right? You have S data, so watch this carefully. Okay, S data is, you have a dictionary of B, C, and D, right? This is key and this is value. B, C, D key, you have some value here. But then if you provide your own index, right, which is of type list here, and then you're providing A, B, C, D, B matches with B, C matches with C, and everything is fine. But for the one, it did not get any value, it just applied, it just put NaN. Okay. So that's how, I mean, that's why pandas are very powerful. You know, some of the missing data. So it's assigned. It's not as such a value. It's just saying that it's not null. Okay. So pandas are powerful in the sense that it is able to identify whichever are missing data, and then it assigns something to it. I mean, Vishnu, that's partially correct. It's assigning something, but it's not exactly the data that it's assigning. Okay. So that's about it. I mean, and then it's able to match internally. Look at the programming that must have gone with inside it, right? So when you do this, it's just a matching of this to this, and then whatever is matching, it will retain the same. Whatever is not matching, it apply NaN, so on and so forth. So there's a lot of work that has gone inside pandas. And then you can also do this. What will happen there? Yes, it will. I'll show an example later on, Vishnu. There's an example that we have. Okay. So here it goes. When you do S5 into 2, S5 was this A, NaN, 100, 150, 200. Now when I multiply it by 2, it just multiplies with all the values of the series. Okay, makes sense, guys? Also, moving forward. Random 5, this is fine. Now, data frames, right? This we were talking about series. Now let's talk about a little bit about data frames. These are just a basic concept that I'm walking you through so that we'll be able to understand some of the complex stuff later. Now in this case, I have taken a series. Okay, it's again like a key value pair, right? If you see here, I've taken this is as a column name. You can think of this as a column name, and I've taken a series which has certain index. I've taken another 2 series, which is again another certain index. I pass this complete series data, which is again in these braces inside my data frame, and then let me print my data frame now. Okay, so when you look at the data frame, this is column, right? Column value. If you compare this with Excel, now you'll be able to relate to it more, right? See, you just compare this with Excel. On top of your Excel, you write your column names. So this is your column names. These are your values, and this is your index A, B, C, D. Now, in my first example, in my first column, right? In one column, I have only 1, 2, 3. So 1, 2, 3. Whereas I do not have an index called D. So in this case, it's just null. There is no value here. In my second example, in my 2 column, I have 1, 2, 3, and 4 as values, and I have index A, B, C, and D, right? So it will assign everything properly. Make sense? This is how your data frame would look like. Now, this is my data frame. One here, you're able to see data frame. This is another similar example, right? 1, 2, 3, 4, which I'm not going to show. And anyways, this is what I'm going to share with you, so you can practice it yourself. And now, when you do D1, it's the same thing again. Data frame, print of DF. Now also the other thing that you can do here is data frame of, I just want one column. How do I do it? I just get one column, right? That's what it says. You can do 1, 2, and then you can also add a new column to it. Let's say I want to add a new column. So you can manipulate this as well. So whatever you are able to do with Excel sheet, most of these data science individuals, right? Data science folks or data science scientists in any office that you might see, they will work a lot with Excel. I'm sure you would have seen that. Your business analyst works on Excel. Your data analyst works on Excel. People just like to work on Excel, right? So you need some feature which are which are in. So while creating Pandas, right, they thought of a feature which are similar to Excel, and then they started putting these things in there. So whatever you do it in Excel, you can do this here as well, but with ease of coding, and you can automate the whole process that you can do in Excel. Not that you cannot automate the whole process in Excel. Excel is quite powerful. It has its own macros. You can create your own pivot, etc. But it's just that with programming here, you can slice and dice the data. You can cleanse the data. You can automate the data. You can create jobs which will run automatically. So there are it's much more than Excel. But the idea was to give them something which will help calculate, or which will help data scientists in order to find a solution faster. Now, if I want to add a new column, let's say I have only how many columns? I have 1 and 2. Let me just comment this. If I do this, and all I'm doing here is I'm taking the column 1, multiplying by 2, and assigning it to my new column. That's the new D1. Okay, data frame D1, it's not defined, right? Correct. So it's my data frame which has been defined. So this is how it is, right? You had 1 and 2 as the column here, and now I have 1 column, 2, and then this is a new column, which is a multiplication. It just multiplies with 2, 1. 1 into 2, 2, 2 into 2, 4, 3 into 2, 6. That's how it is here. Okay. This is like 2 plots on 1 graph. I mean, it's more like a matrix. Now this will be 3 into 3 matrix, right? In this case. Okay, you didn't get me. Okay, so here your data frame is like a matrix, Vishnu. In this case, it's more like 3 into 3 matrix. Okay. Okay. Great. So now print series, and okay. Here. I'm just trying to show you some things which are important. Other things are here, right? And you can have a look at it yourself. Series. Okay, let me do this. Now I created an object, and okay, this is about reindexing. I have this index. Okay, excellent. So coming back to my, okay, let me take this back. So to my series, right? Now in case of series, okay, this is my, now you see this, what will this give me? I have green, yellow and red. I have indexed is that 0, 2, and 4, right? This should print me 0, 2, 4, green, red, and yellow, green, yellow, and red. But what if I have to reindex the whole thing? I mean, those index is not correct, right? It's let's say I had a lot of data and then something in between got deleted, and then I just have 0, 2, 4 and 0, 2, 4 index, which I want to reindex now. And this is one scenario, right, wherein you could use this function. So for the first time, your green, right, yellow, and red is 0, 2, and 4. That's fine, but I want to change it, right? I want to reindex it. So what I do is I put object.reindex of range 5, then it says 0, 1, 2, 3, 4, and then your 0 is green, your 1 is NaN, 2 is yellow, 3 is NaN, and then 4 is red. So what it is doing is just putting a value with which you'll be able to identify what are the things that is missing here. And then let's say you want to repeat it, right? You want to repeat some of these values wherever it's blank. So what you do, you say fill values and then you say blank. Let's see what happens now. So wherever you had put NaN, you are able to replace it with black. And what's that? Object 1 equal to green. I didn't get it. Are you able to assign? Do you want to assign something here, Vishnu? Okay. So that will be object 1. So you are saying something object 1 equal to, let's say, ABC, right? It does not work, Vishnu. Okay, yes, ABC, it does not work, Vishnu. Okay. So these are some of the features, right? These are some of the features. I mean, Pandas has been created so as to do something in, so as to do your analysis on statistical data mostly, and to plot graphs, right? Some of the features of list are available here. So this is more like a, okay, that's, sorry, okay, object. Okay, it works. Some of the so it works like a list. Okay, thank you Vishnu for pointing that out. Yes, it works like a list. Some of these things work, some don't. But basically the point is that, you know, these are things that you do in order to first slice and dice your data so that you can finally plot a graph, or maybe provide this as an input to your machine learning program that you have used, right? So now let's see here, and thanks for pointing that out, Vishnu. Okay, so this object.reindex, when I do this, now you have object 1 equal to ABC. Python is, yes Vishnu, it's extremely powerful. Each of this package is it's a complete book in itself. I mean, Beautiful Soup is a book in itself. Pandas is a book in itself, right? It's more like an independent programming language itself. So okay, so that's about if you want to fill black. Let's say, for example, you just filled everything as black. Let's say, for example, you just want to fill it, right? Which means you want to fill with already existing values. Okay, and what I do here is, now there will be nothing, right? Okay, I'll have to create a new series. Basically, what ffill would do is it would fill here. I do not have, one second, let me run Python. Okay, just a second, I want to show you one more example as well. Okay, it's NaN here, right? So if I do an index and methods ffill, okay, you see this here now. So what happened here was, I had this as my series, right? Green, and wherever it was, wherever there was no data, it just put as none, NaN, and then yellow, NaN, and red, right? Now I just want to fill it with whatever is existing. So it just takes the first value and then if it does not exist in the second one, it just overwrites it. Takes the third value, right? It prints the third. In fourth, it goes and checks there's no value, so it just overwrites it. So on and so forth. So these are some of the techniques using which you can fill the data as well, for whichever is not there. And this will be required in many cases, right? Many cases while you are, when you are playing around with data, you might run into a scenario where you would need some data instead of leaving those empty. And in these cases, you can use ffill. Now, df.sum. Now we are going into interesting thing. Okay. Now what's df? Print. When I do print df, I have this, right? Now what happens when I do? Now see the power of pandas now. Those were simple stuff that we were looking into. Now if I do df.sum, see 1 how much? 3, 4, 5, 6. Okay. It just summed up all the columns in one shot. For 2's, 1, 2, 3, 4, it just summed it up. 3, it just summed it up, right? If you want to, let's say for example, find mean, right? Mean. What's the mean of 6? It's 2. 10, and then just 4 values. It's 2.5. Again, you have 12 mean, which has only 3 values. Isn't this interesting? Now, not just sum and mean. Let's say, for example, I just comment this out. What happens now? Let's go and check. You see this count, mean, standard deviation, minimum of the values, 25%, 50%, 75%, and maximum. You see this? Now we are getting to know pandas, okay? Makes sense? Now just imagine the usage of it when you are dealing with statistical programs or statistical packages, etc., statistical data, where you want to calculate, let's say, weather data sets or any kind of other data sets that you might have. Okay. The new column, Naveen, I have just added a new column, right? You see here. You see, I added a new column. Is the 25% of the total values. Let's go and check here, right? So, what's the total value here? 6. And what's the 25% of 6? 1.5, right, Vishnu? 50% will be 2. That's what it is. I mean, it's just, you know, it's for folks who are doing statistical analysis and stuff. You know, they would need this many a times. You know, they would need 25%, 50%, etc. Yes, Deepesh. It's called quartiles as well. Okay, so just imagine, you know, how powerful it is, and we have not even explored, you know, quarter of it. So let's go describe. Now let me go back to our slides, right? And there are a couple of more things here, and there are some things here and some things on my slide. So I'll explain you whatever are the differences. You know this, right? We saw the index part. We also saw, you know, the range. How do we do it? You know, how we can assign index to each of these values here. That's what it has been done here. We can also pull out the series. We can pull out first or second values of that series. We can also re-index whatever is there in the dictionary. Let's say dictionary, I have passed 1, 10, 2, 20, 3, 30, and then I have given index 1, 2, 3, 4. So it will just match 1:1, 1, 2:2, 3:3, and then 4 there is nothing. It will just put NaN. Right? We can use NumPy operations on data. We can just use series into 4, and then it will just multiply everything. 10, 20, 30 becomes 40, 80, and 120. Right? And now data, you have, let's say you have some data like this. It's a dictionary like key value pair data. Key is this one country, and your value is a list. Right? And then if you put that data in data frame, you'll be able to see something like this, which I've explained, right? See, this country is one column, year is one column, population is one column. Okay. Now, again, it's the same example here, data frame. You have the same example, creation with Dicts of Dicts. See, only difference here is that you had inside your dictionary you had a list, right? Key value pair. Key is a normal key and value is a list here. In this case, key is a normal key, whereas value is a dictionary. Right? For that also you have, and then in this case now the way it compares is 2012, right? US, India, so it matches the value. 2012 has 30 for US and 20 for India, 30 for US and 20 for India. So each key is a label for its value. This is a key value pair. Now, you mean the output, Vishnu? Yes, I mean this is more like dictionary. You can think of it as an output. You can think of this as any other key value pair as well. I would not say it as a label, Vishnu, as yet. Some key might have value of 10, but some would have assignment of 10 as well. So it is not exactly output, but this one gave no label for year. I mean, we do not have year right here in this case. I mean, this is more like an index in this case. Okay, if you are talking about index and label as the same thing, then it's the same. Okay, Vishnu, I get you. Yes, you are right. Okay. Now in this case, right, you have see this index value, key value pair, right, and then it compares both the index, and you have 2012, 2030. Now if you just want to access one part of the column, you can just do that with country as well. You know, you get like this, and then if you want to, and then when you describe it, you already know what you get, right? There are a lot of things that you get when you describe it: mean, count, standard deviation, minimum, maximum, etc. Now you have seen this. How do we add a new column? We have also seen as to how can we add a new column to this. It's simple, you know. You just have to say new column, and then you have to put the values. How many ever values you want to put. It's not necessary that it has to have all 4 values. You can have 3 values. Maybe it's a list, right? You can have just 3 values, and the rest of the values will be applied as null. NaN. We have seen how we reindex this. When we do reindex, it will properly reindex this instead of you know, haphazard index here. Fill value Python, again this is you know, you have a range of 6, 0, 1, 2, 3, 4, 5, 6. When you reindex this with range, and then you fill value Python wherever it is NaN. In this case, let's go and see this, right? You have 0, 1, 2, 3, 4. You have NaN, Hadoop, NaN, and Cassandra. So fill value Python will say Python, Hadoop, Python, Cassandra, and then, you know, and then whatever is there, you know, whatever extra values is there, it just put R, let's say, and then it just index it. It's very simple. And ffill, we have already seen what an ffill is, right? It will just put, if it is for the first time, it will not put anything, because if it starts with NaN, it will just be NaN, otherwise it will just repeat whatever is there previously. Okay. And then we can apply individually also. Instead of doing data.describe, what we can do is we can apply functions like sum, min, max, head, count, tail, etc. So, you know, here you do sum, it sums all the columns, you do mean, it gives you all the mean, and so on and so forth. These are simple functions. I'm sure, you know, you are understanding this right now, because there is nothing much to explain. It's just that you'll be able to use it, you know, as and when you practice more. I mean, that's how you'll be able to remember and use it. And then when you do describe, that's about it. Okay, now let's go and see how do we load the data. How do we load data in Pandas? Now see, it's very similar to other programming language that you might have done. Okay. Now see, I am loading this data. I have a transactions data in my this particular location. So this is a CSV file that I have. Some data, okay. You don't have to go into the intricacies of data. This is some data that I'm loading here, and all I want to do is I want to print the data. I want to read the data. This is just about reading the data. So it just read the complete data. So there are lots of record here, and then it's just reading it. Okay. And then see, it's because it's a huge data set. That's dot 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 dot. That's lot more data here. So basically, this was to show you how to read the data. Now you can read the structured data. It works fine with JSON, XML, HTML. You can read that as well. You can read Excel as well, but you'll have to use XLRD or Open PyXL. Okay, these are third-party packages. Now you just have to go that and download it. If you have to read Excel, you just have to go here and then you have to import one of these packages. Open XLRD. Let's say I have not installed XLRD. So if I want to do XLRD, I just go ahead and say install packages. That's all I have to do. And then database, Pandas IO SQL module, it will be able to read from database as well. You have seen how we do that in SQL-Lite, right? You are able to, you are able to hit that. You are able to create tables. You are able to read from there. You have connectors using which you can connect to databases, pull the data from there, and using Pandas also you have input output SQL module. So Panda read, that's how it reads. And now my data is not so good. Otherwise, I could have described it, right? If I say, let's say, this will, because my data DSCRIB. Right, so it gives me this, okay. Count is this much, minimum is this much, standard deviation is this much. So for this data, right, it's huge. So for all this numerical data, it just took and it just counted it. It gave mean, standard deviation, maximum, etc., and so on and so forth. So my data did not have my column, so the first record it took as column, right? So that's how you are able to process data in Python. It's extremely powerful. You just have to have data in your Excel sheet, and you can apply one of these packages so as to be so that you can get one of these results. Now going back there, also there are some of the functions that you would want, you might be interested in, like length. So if I say length of data, it will give me the number of records there. Okay, let me comment this out here. I do not want to print this. Okay, so let me comment this as well. Head, I do not want head. Data.columns. Right. So you see this, it gives me 49,999 as the number of records. So which is my length of data. Now data.columns, it will give me all the columns or the first record, right? So it does not have any columns, so it just took out the first data and then it's giving me as columns. So if I just want to print the first 10 records, I can say head of 10, right? It just gives me 10 records, see 0 to 9. Now, because it's not able to show it here, it's just that the next set of columns, 1, 2, 3, 4, 5, 6, 7, 8, 9. So these are the total columns that I have. 3, 3, 6, 3, 9, right? So that's what it's displaying here. So that's about at high level. I think that's about it on Pandas, and it's again the same thing. Okay, see these, you have seen this merging tables. Let me talk about that concept briefly at a very high level. Describe now length of data, columns of data. And see head of 2, you just get 2 records. You can also get, functions can also be applied on columns also. So here, one second. So you got it, right? Okay, you have head, tail. Dipesh, you have head, tail. How do we save the data to a file which we can use to see? This is so basically, Vishnu, what we have done is we are reading this. You can open this in write mode and then write it the way the way we have done it, or you can use any other Python modules as well. If you want to use this is how you are opening a file for read and write mode. Make sense, Vishnu? Or you can open some other file for the write mode and then you can write it. It's simple, like what we have done for other Python, read and write. The same can be applied here as well. Yes, Deepesh, to some extent it's similar to R, and Panda has taken the best out of R, matplotlib, etc. So it's similar. If you know R, actually it will be easier for you to understand all this. Okay. But the advantage with R right now is that you have R Hadoop. Okay, so it's not an in-memory operation anymore right now. You can run R over Hadoop, and this complete it's altogether different ball game. But prior to that, we just had R, right? With R had its own limitations. So anyways, let's move on here. Now see, you can go to ID. If it is ID, you just want the two IDs here. This ID, like you just do ID of head of 2, and then you say ID of max, you get max. Simple functions, right? And then you want to draw a graph. I'm not drawing it right now. I'll draw it in some time. You just say data.open, and then you draw an histogram, right? Data age, you draw an histogram of age, and then you just say so for age you plot it. Now, and then you want the first row. We can do it. One second. Okay, let me comment this. Let me comment this. Let me comment this. Okay. You see this? So it's assuming this is a column. Okay. First column is assuming it is column, so it's giving me data here. Now see all this I row. So basically, if you were in this page, right? If you were looking at this example, first name, last name, age, and occupation. So here in this case, first name, last name, age, and occupation, including ID. So if you do 1, you get this. If you do 2, you get the second row, and so on and so forth. The ID is 402, 443, 403, and then so on and so forth. Right? If you do 3, you get the third record, so on and so forth. It's very good for analysis. And then there are some more actually. You can apply filter also. You say volume equal to data, and then you give data ID of this 4 and 502. You just get that, right? You filter it based on writer, you get this. Okay, so it works like an SQL as well. Where you are applying your select star from table, where table name or column name equal to value. It works like that as well here in this case. Pandas, we can merge table. It's more like a union. Okay, so how after reading from CSV file, how do you want to save this multi-dimensional array? I mean, then you cannot save it in CSV, right, Vishnu? Then you'll have to do it in Notepad or something, and then you'll have to read it from there. You'll be able to write. I mean, in this case, whenever you do describe also, right? I mean, it's coming row. it might look like multi-dimensional to us, but the way your system would understand the data would be according to the row, right? Each row will be printed. That's about it, Vishnu. Okay. So again, this merging table. Yes, Vishnu. Okay. So you're merging your, I think I have an example of merging. It's similar. Okay, here. Okay, so see, these are the two data frames that I have created. Okay, let me just take one by one at a time. So what does this do? I have dictionary of range 0, 1, 2, 3, right, which is ID here. You see this is ID 0, 1, 2, 3, and then age is my random number between 8 to 31, and you have the size is 4. So it starts with 20, right, and you have 22, 20, 22, 25, 30. So this is what it has, 18 to 31 with size of 4. Okay, now my second here, my second data frame is, you know, I have range of 3. Let me comment this so that you're able to understand it better. Now I have an ID which is range 3 plus 3. That means I have 0, 1, 2 and 0, 1, 2 again, and then some random number. Okay, don't worry about this. Some random number of size 6. Now if I have to add those two, what do I do? Okay, let me go here and then print and let me just merge it. Okay, just for a reference, right? Where all I'm doing is I'm doing a pd.merge. Oh, is it, Vishnu? My video and audio is not in sync, is it? Now, are you able to look into my PyCharm? Hey, Vishnu, are you able to see my PyCharm? Guys, are you able to hear me? Okay. Okay. Vishnu says a lot of video lag. Amit, yes. Dipesh, Sayed. Okay. Naveen says it's good for me. Okay. So I'll not change it that frequently, Vishnu, in that case. Are you able to see my screen now? Okay. I think you're able to. It's good. It's okay. Thank you, Amit. Thank you, Vishnu. So now when I run this, now see in my first place I had age, right? In my second I had score, and ID is same in both the cases, right? So basically all it did was it merged the two. That's all. It took this data 0, 1, 2, 3, 0, 1, 2, 3. Now ID matching 0, 0. So this scores 27 and this 27 and this value. Again there is a matching of 0 with another 0, so it will be 27 with some other values as well, some other value as well. So it's more like you know, you're merging it. It's more like you're doing a union between these two data sets. So that's about it. I mean, you might need this feature whenever you are you know, trying to merge these two data. I have an example here wherein we'll be using this feature. So this is how the data sets are merged. I mean, it's pretty simple, right? You're able, I'm sure you're able to understand. It's more like an inner join on the table. So if you think of this as a table, it's more like an inner join. Okay. So this, okay, now let's go to summary. Built on NumPy, SciPy and Matplotlib. Basically, it has taken out the best of the features from NumPy, SciPy and Matplotlib, and then I have created Pandas. arrays with labeled access that supports heterogeneous data, right? It's index data, usually works in conjunction with other scientific stack of Pythons like SciPy, NumPy, and scikit-learn, right? Basically, Pandas is an combination of NumPy, SciPy, and Matplotlib. It has all the powerful features from there. So you can, so as to process your data, you can use Pandas, and you can use maybe scikit-learn for implementation of machine learning algorithms on top of this. Have more features than R's data frame, right? So it has actually more features than R data frame, and hence people are preferring to use Pandas over R. Does automatic and explicit data alignment and has group by reshaping, time series functionality, fault tolerant, uses the best feature of the popular data analysis environments like MATLAB, R, Stata as well. So this is what we have been talking about. So applications, Pandas like NumPy help solving data related issues, mostly in the field of data modeling and efficient computing. Okay.